So today's lesson is going to be kind of unique and different, but it's definitely going to be something that's of interest to everyone. And that is, how do you get research with professors? So a lot of you have been taking this class and taking diligent notes and really keeping up with all the material, and that's really great. But we must ask the question at some point that, well, what does all the work lead up to? Why do we need to learn about organ engineering or CRISPR or and like cardiac engineering, anything like that? And well, while it's great to know and really interesting for personal development, it can also be used to enact tangible change in the world. So the purpose of Scientists of Tomorrow, this entire program and initiative we're running with students from 12 different countries, is so that we can get this broad level of education to catch you all up with the level of biotechnology that's going on in the world right now, and give you the fundamental understandings of lab techniques like PCR, gel electrophoresis, like that you'll see in a wet lab, and then prepare you to actually do the research yourself. So as a lot of you know, when you go to university, when you go to college, you can have these research opportunities with professors. But what some of you may not have known is that you can do them as secondary school students as well. And in some cases, even middle school students, but let's stick to secondary school students as well. So what we'll do today is, firstly, we'll walk everyone through how this whole process will work with, getting professors from different universities and working with them and researching with them. Then we'll go through a quick maybe 10 minutes on the JMA ambassadorship, which is something I mentioned way back with our first lesson. And then thirdly, we'll start with some introductory research techniques with DNA. So to kind of give you a head start for the fundamentals of lab work, and we'll continue that next time. So with that, we'll begin our lesson. So yeah, so our lesson today, like I kind of precluded to in the last slide, is on research applications. So with this surrounds a couple of questions I'm sure a lot of you have, especially if you haven't researched before or know about it before. So firstly, what is the purpose of even researching? Why should we even research? Well, although that's a very good question, the results and the effects are very, very clear. That students that do research early on in high school or secondary school have a huge, immense advantage when they go to college and go to college as an undergraduate. Because as an undergraduate, when you all go to the amazing universities you eventually will, a lot of people have a research background. A lot of people understand how to, can work with this kind of material, and that enables them to go and do higher level work at labs. And a lot of people don't have any research experience, and then they have to start from scratch, and then it becomes difficult for them to kind of catch up while managing their college work, while also trying to fit in and live their live the college lifestyle. So it really helps in getting a head start and understanding the fundamental techniques, right? As with anyone riding a bike, if it's your first time riding a bike, if you're 5 years old versus 50 years old, you're going to struggle initially. And that's why it's the best to do research early. So it'll give you the best head start possible. And also there are a lot of personal benefits aside from how you grow as a scientist, that it'll help for scholarships. It'll help for when you apply to universities, because universities want to see students, specifically students across, continents like Africa, that you have access to doing some level of scientific research. And it really gives you an edge up, because for a lot of international students, they don't have any research experience in universities, and specifically, you don't have any research. They don't have much research experience in the university they're applying to. So, for example, let's say that you wanted to apply to Brown University or Yale University, and you were able to do some research there over the summer before applying. That gives you a major edge up, and then maybe you can even get a letter of recommendation from the professor you're working with. And that would make you really stand out and really increase your odds of getting into these top tier universities. And a lot of students do this from USA and eventually get accepted to the university that they've been researched at, because it shows that not only do you have an interest in your university, I've actually done research with the university, and I have a professor from a university to vouch for me. So it's a strongly encouraged thing. You learn a lot of the fundamentals of lab research. You learn what it's like to go through the scientific method, set up an experiment, work on the specific parts and the specific procedures that we'll also be teaching today. So like gel electrophoresis, PCR. So it'll be very, very useful, definitely very useful all around. And then the question becomes, how do you do it? And that happens when you email professors and all that. And we're going to break that down to step-by-step process. So the first step, and this sounds very generic, we'll soon get very specific very soon. But the first step is, and I know it sounds kind of cheesy, but find your passion. Find something you really love. And you need to ask yourself a couple of questions as guidance. That firstly, what do you love? What is a subject that you can really get lost in, that you just can think about for hours and hours and hours, and just dedicate, that you might even dedicate your life to? And obviously you don't have to, right? A lot of people think that they're really interested in the brain, and they do research and they realize, you know what, the brain is a little too specific. Actually, I really love the lungs and the respiratory system. I might do research there. So it's always flexible, but find something that you love and not something that sounds cool or something that someone else wants you to do. A lot of students make the mistake of saying that, well, you know, I guess it would sound really cool if I said I did neuroengineering, but maybe they really, really just love the pulmonary system, or they really love hematology, like the blood system. So do something, even if other people might not love it, do something that you love, and do something that you can voluntarily see yourself reading about in your free time. Like, do you see yourself, you know, reading about like stem cells, or reading about organ engineering, or reading about cancer therapies in your free time? What do you find really meaningful and has an impact for you? Maybe it's because you lost like a relative, like a grandparent, God forbid, to cancer. And you're just so fascinated with it that, you know, you see yourself spend hours and hours just researching and reading articles and learning more about this space. Do something you love there, because then when you have that interaction with your professor, it comes off as earnest. A lot of people make the mistake when they, we'll get into this later, but I'll mention it now. A lot of people make the mistake when they meet with professors and they think that, well, professors, when they take on students, want to take on the smartest, brightest, most diligent students. And while that might be true in some cases, that's more for when they're taking on PhDs. When they're taking on undergraduate students or high school students, they know that, well, obviously you're in high school. You're not expected to be a world-class scientist. You're not going to be, you know, Einstein when you're just 16 with no experience. No one is. They're taking you on because they see something. They see themselves in you. They want to give back to their community, because at every point, even the smartest, you know, the smartest brown professor at some point was just another high school student who had no idea about research. They also screwed up in the lab. They also had no idea what PCR meant or what DNA was. They all learned from scratch, and they want to give back, and they want to give back to someone that's deserving, not someone that wants to do it as a line on their resume, but someone that really loves the material. And we'll get into this when we get into the email frames and everything. And the best way to kind of go about this is you need to look at two things. Both are SOT lessons, our Scientists of Tomorrow lessons. So if you want to find topics, you can look at all the Scientists of Tomorrow lessons we've taught, from nanotechnology, CRISPR. If you like agriculture, then aquaponics. We did organ engineering. We did stem cells. We did induced pluripotent stem cells. So we've done a host of things that you might find interesting. But if you don't, that's okay. You can look online. You can look for videos on cutting edge science. You can look at videos for, you know, interesting nanotechnology, or whatever you like, or articles or whatever. And you might come across a topic that we haven't taught, and that's totally okay. Just find something that you're interested in, and you can stick with that. So let's take, for example, like in our kind of step-to-step guide, let's take, for example, iPSCs. Let's say you're interested in induced pluripotent stem cells. And just as a quick 10-second recap, induced pluripotent stem cells was this whole process where we could harvest a random cell from a donor. So let's say it's a somatic cell, like a skin cell or like a hair cell. And we could add different kinds of transcription factors to change and degenerate it back into the original stem cell. So really, this is like taking like a cake and degenerating it back into flour so I can make cookies with it instead. It's a very fascinating process where we can then take the stem cells and then differentiate it into a neuron or a blood cell or any kind of cell that I want. It's like taking a skin cell and making it into a neuron. Very fascinating process. So let's say, for example, that you're interested in iPSCs. Then now that you've found something you're passionate about, the next step is to email professors and reach out to professors. So this has three main sub-steps. Like, firstly, you need to find a professor. Obviously, you need to see someone that has the research that you want. Secondly, you need to understand their research, because even in a topic as, you know, seemingly specific as iPSCs, many people, like, there are hundreds of labs out there that do their own unique, different work. So some might be using iPSCs for myocytes, and we'll be looking at a lab like that just soon. Some might be using it for cancer research. Some might be using it for engineering organs. So really, there's a host of different applications out there. So really make sure you understand what the lab is working in. And then you reach out to them and email them specifically, so you show understanding of what they're working on. And then you maximize your chances of having them reply back to you. So I'll get into all these right now. So there are three main ways to get professors. So firstly, you can do an online Google search by topic. So like we said with iPSCs, if I'm interested in the topic of iPSCs, I can do a Google search by the topic. And we'll look at that like right there in the next slide. Secondly, I can look through university department lists. So if I'm interested in a subject, if I say, you know what, I'm interested in cell biology, or I'm interested in pure biology, or I'm interested in the field of chemistry or physics, then you can search up university department lists of biology professors, and they'll give you every single biology professor and their contact information. So you can go and look at their research, you can go and reach out to them and see if they'll, give you a helping hand. And that's a really awesome thing that they do. And lastly, there are certain platforms like Vevo.Brown, and we'll look at that are specific to university, but you can search up both topics and professors, and they give you hits. So this might seem confusing, but I'm going to go break it down one by one and give you in-depth look at every single one of these. So let's start with the blue one, online Google searching for topics. So this is it's very simple. And for all of you that are interested, I'll be sending all these slides to you. And that's why instead of Google searching in front of you, I included these in the slides so you can see for yourself. So don't worry about losing track or anything. So if I was interested in IPSCs, I would type in the name of the topic plus the words university research labs. So because I'm interested in IPSCs, I'll type in induced pluripotent stem cells, the name of the topic, and then type in university research labs. If I happen to be interested in nanotechnology, that's a nanotechnology research, nanotechnology university research labs. So just based on this inquiry, you can see how I have scholarly articles. So these are articles you can read for more background information, articles you can read to understand more about the topic. And then I have research by Yale into IPSCs and their core laboratories, research by Stanford, the Joseph Wu lab that does research into the underlying development for stem cells, induced pluripotent stem cells, research by Johns Hopkins. All of these are wonderful, extremely prestigious institutions, and they have obviously high quality research. So then the next steps you want to do are actually read through the website, read through their work. So understand what is firstly the current work they're working on, and secondly, what is prior work they've done in previous publications. And then you want to look for emails in the links. So now let's pretend that, this caught my eye because it said a specific lab, and I think this might be promising. So I click on the Stanford Medicine site. If I do that, then this exact page pops up. And I actually did this last night in Google, and I copy pasted the pages here. So this is the exact page that'll pop up if you click on that. Then there are three things I want to take note of, and the decreasing size indicates decreasing order of importance. So firstly, the most important is, well, look at what does a lab do, right? Is this maybe this lab didn't work on something that I was interested in. So they have a lab summary, and this is very well organized. Not all labs websites will be this well organized, but this one is very well organized. So they say right here that they work with gene therapy. They work with all kinds of biologists, cell biologists, biochemists, imaging specialists. So there's a lot of interesting roles in this lab already. So maybe you don't like cell biology. Maybe you might be interested in the imaging. Maybe you might be interested in biochemistry. There's lots of interesting roles here. And they say that they're basically using stem cells like iPSCs to better understand immunogenicity and tumorigenicity, which relate to immunology and tumors and the spread of tumors that they're using iPSCs for. So that's already really cool. So I'm really interested in immunology, let's say, and cancer. So this might be a really interesting lab for me. So just as a litmus test, over here, they have some of their most recent research that they're using iPSCs for cardiomyopathies, which are different kinds of heart diseases, a state of heart disease, and they have specific articulations here on how they're using iPSCs for that and preventing cell death. So let's say you read through this and you got really interested in the material and you thought it was fascinating. Well, a couple of things will happen. Firstly, you might not understand every single word here, and that's perfectly okay. I remember when I first got into the whole research thing, I was pretty young. I was in 8th grade or so, but I didn't understand half of the words on the site. Almost every other sentence had 3 or 4 words which I didn't understand. Right here, some of you might not know what hypertrophic means. It's when cells/organs grow and enlarge, and that becomes obstructive in the body. You might not know what cardiomyopathy means. You can search all these words up. So literally just copy the word, paste into Google, and click definition. So put, hypertrophy definition, and then it'll define the word for you in simple layman terms. So definitely, do that. So to recap, we're reading a quick summary of what the lab is about. We're reading into some of their previous research. We can look at their previous publications to see what is prior work they've done and understand, well, what is this lab working on? And then lastly, you want to look at the people. And this is the most important, I would argue, that when we click on people, right, it shows us, well, who's part of the lab, and it shows us their contact information. So when we want to email them, well, obviously we can't email them if we don't have their emails. So right here, it gives you their email. And this is the principal investigator. So some background on how a lab is structured. So they have a PI, a principal investigator. They call them PIs for short, that leads the research. So they're the people that are the head of the lab. You can think of them as the CEO of the lab. They're the ones that that manage all the research, that, you know, give people, delegate roles, that apply for grants, and they're usually very, very accomplished researchers, very intelligent people, and we have a lot to learn from them as individuals. And beneath that, we have postdoctoral fellows. So postdocs, for short, postdoctoral fellows, they also research in the lab. They're extremely intelligent. Most of them have their PhDs, and they're doing research in the labs. So what I'd recommend is that, well, right here, you know, if you click on each of these names here, this one is really well organized. That's why I chose it. It has all the postdocs' emails as well. So if you want and you really like the lab, then you should definitely email the PI, but you should also send separate emails to all the postdoctorate fellows that work there. So find their emails and email them and say, hey, I thought the work you were working on was really cool. Can I join in? Can I join in? So that would be, or can I learn more? And that would be really, more effective. Because think about it, maybe the PI is really busy. They're applying for, you know, hundreds of grants. They're doing tons of high-level research. They might not get back to you. But the postdoctoral fellows, they might have less work on their plates, or they might be less busy, or have less emails cluttering their, you know, their inbox. So they might be more likely to respond. And let's say, and I've had cases where, you know, the PI didn't respond to me, but then a postdoctorate student responded to me and forwarded it to the PI. So then the PI noticed, because, well, it's someone in the lab that forwarded it to him. So it's this kind of networking sense. So always reach out to all the postdoctoral fellows you can to maximize your odds. So that's the first way, doing a Google search by topic. And I hope that was clear for everybody. So, and definitely ask any questions in the chat if it wasn't. Does anyone have any questions on just the researching by topic? And I'll pause for 5 seconds for anyone to type out the questions. Okay, great. So, and again, if I'm cutting you off, just finish typing your question and I'll get to it. So the next thing we want to look at is looking through university department lists. So what I mean by this is that, well, universities have tons of, let me just explain it first. Universities have departments for every single subject, right? So most universities, you can major in something like cell biology, like chemistry, biochemistry, you know, I'm trying to think of other, physics, you know, inorganic physics, all that kind of stuff. So inorganic chemistry, sorry, all that kind of stuff. So these are, I'm just listing STEM fields. Maybe you might be interested in sociology. Maybe you might be interested in psychology. So there are almost every single subject you can think of, universities have some kind of department for them. So the way you approach this is that you type in a university that you're particularly interested in. So I'm taking, for instance, the example of Harvard. So obviously they're a prestigious institution. They have a plethora of research opportunities and good graduate programs. So you type in the name of the university, followed by the subject, followed by the word professors. So let's say I'm interested in cell biology. I type in Harvard University, so university name, cell biology, the subject, professors. Harvard University cell biology professors. Let's say, you know, instead I was interested in chemistry professors at Princeton. I would type in Princeton University chemistry professors, right? So it's a very simple kind of, you know, format that you can use, and then a huge list pops up right away. I have all the faculty websites, I have the faculty profiles. So let's say I click on one of these. If I click on one of these, I have this whole list pop up, and you can see here, like this is, I only included a screenshot, but look how small this bar is. There is at least, you know, like 30, 40 professors on here. And here's what's great. All of these professors' names are linked. So over here, you have a quick, it gives you a quick background on what they do, like their background and their education. Then it gives you a quick background on what they're working on. If you click on this, if you click on any one of these professors' names, let's say click on the first one, then it gives you their email, and it gives you a website for their lab as well. So I would say this is also really well organized, that let's say you don't know specifically what you are interested in. Let's say you're just interested in cell biology, and that's completely fine. And honestly, I would recommend you do both. I'd recommend you reach out to, let's say I was interested in IPSCs, I would reach out to IPSC professors specifically, but then I would also reach out to professors that just generally in cell biology, because you want to maximize your chances of people saying yes to you. Like people, like you apply to hundreds of labs and maybe only get a couple responses. So really maximize your odds by doing every single thing on this list. So yeah, like you can, you know, find his email, so you can copy paste the email, send an email to him. You can look at his website to find the specific research he does, and you have some of his background here. And right here, you have all the professors that are, you know, in this specific department. So you can just click here on the side and look at every single faculty. And obviously, I mean, I use Harvard as an example, but you can use any university. You can use Oregon State University. You can use University of California, Irvine. You can use Vanderbilt. You know, there's a plethora of there's literally hundreds of universities out there that you can approach. Then the third way we're going to look at is searching in a specific platform. So one I would recommend that I know of, and I think is really nicely structured, is vevo.brown.edu. And again, this link will be in the slides that I'll send to everybody. But if you want to take note of it, go for it. So vevo.brown.edu. So this platform is really nice because if you click on this link, this is the page it takes you to. So over here, you can type in any specific kind of research or professors that you are interested in. So you can type in either type in either fields that you're interested in, like like biology or chemistry, or you can type in specific kinds of research like iPSCs, or specific medical topics like cardiology or obstetrics or neuroscience, and all that list will pop up. So let's say for the purposes of today that we are interested in iPSCs. So if we type that in, then this list of professors that do iPSC research pops up. So then over here, obviously, we have their names and their profiles. If you click on their profiles, then it comes up with this kind of page. And to kind of break it down, this is everything that's on the page. So obviously, we have their names and we have their faculty positions. This person in general, Professor Koem, she is one of the heads of the biomedical engineering department. She is really well researched, really amazing teacher. If any of you are interested in iPSCs and cardiovascular disorders, I would really recommend her. But yeah, so over here we have a quick overview of what she works on. So just to skim like the main parts of the overview, yeah, so she works on therapies for cardiovascular disease. And we just had our heart disease block last week. So all of you know a bit about cardiovascular disease, about stents, about the arterioplasty, about atherosclerosis with the blocking of the pipes or with the pipes constricting and hypertension, how that hurts organs. So we know a little bit about cardiovascular disease. And let's say you're interested in stem cells. So this is a unique combination of these two fields. So she's using engineered human myocardium with myocardiocytes. So what that means is with stem cells, we discovered that you can make them into progenitor cells. And what that means is early versions of certain kinds of cells. The same way that a teenager is an early version of an adult, the same way that a kitten is the early version of a cat, or a puppy is the early version of a dog. These are like, these are like the puppies of the heart cells. So these are, immature heart cells that have yet to develop, but they're right in the middle of stem cell and heart cell. So they're the progenitor cells. So she's deriving them from iPSCs and basically using them to restore the contractility and restore the function of hearts. So this is one thing that I'm kind of showing an example of, but I want everyone to do. So read through their research, read through the summary, and kind of look away. So like look away from it and ask yourself, can I summarize it? Can I summarize it into 1 to 2 sentences in very basic terms, like you're explaining it to a baby, or like you're explaining it to someone who has no idea of anything about science. So these obviously use really big words, right? Myocardium with myocardiocytes, electromechanical function and integration, and cardiac contractility. There's a lot of big, like complex buzzwords in there. But let's say I was just to say that, well, like if someone was to ask you, what are you doing? Well, all I'm doing is I'm taking cells, degenerating them back into stem cells, and then making them early heart cells to go and restore the contracting function, restore functions in the heart. They go and make the heart healthier and the heart stronger. So very simple layman terms, but it gets a point across, and it makes sure that you understand it without having to copy the words here. You can summarize it on your own. So that's important. So the overview here is great. If you click on this email thing, then our email pops up. So right then and there, you have the email to go reach out to. And then these top 3 are the most important. So firstly, it'll show you her publications. So what is previous work she's worked on? And if you click on that, you'll see that she's worked on lots of stuff with like stem cells, with the body, with bioengineering, with biofluidics, and with biomaterials. That's what I was looking for, with biomaterials. And so you get a sense of, well, she's a biomedical engineering professor. She uses technology and medicine, very interesting combinations. You can look specifically for her research. So this will show you all the research projects that she's been working on. So you can get a sense of, you know, maybe this isn't interesting to you, but there's a past research project that she worked on that you might want to learn more about. So that's always worth reaching out to and learning about. And lastly, her background. So this is less important, but it kind of shows you, well, where did she go to school? Where is she from? Just some quick details about her. And you might be surprised. Some professors actually might be from your country, or actually might be from, might have majored in something you didn't expect, like English. That might match with a similar background or interest of yours. So that's always kind of cool to look at. But the most important thing here is the email and the overview. So let's say that I wanted to construct, actually this, yeah, before I don't want to get ahead of myself. So let's say I wanted to go and reach out to this professor for Professor Koem. So what I do is I need to understand the research. So like I said, read through the overview, read through the background, skim the prior publication to see what have they done before, and get a general sense of what they do. And this is also equally important. I said this for the last, I said this before as well, but make sure that you Google up every single term you don't understand. So right here, you might not know what the field of regenerative engineering is. You might not know what contractility means. You might not know what a myocardial infarction is. And that's, you know, that she's nice here and defines that that's a heart attack, but maybe you didn't know what that was. You might not know what what every other word in this sentence means. But what you should do is not only should you Google them up, you should create a small document, like a small spreadsheet. So open up a Google Docs, open up Microsoft Word, or even write it down in a notebook and say, well, myocardial infarction means heart attack. Myocytes means early version of heart cell, and define them in easy to understand words. And Google makes them into easily understand words if you type in, you know, myocardiocyte definition. So that's all well and done. And at the end, the goal is that, well, if you've done a lot of research into one specific topic, then you'll understand all the words that come up. For me, when I was, to give you a 10-second story, when I was in 8th grade, I was really fascinated with the topic of oncolytic virotherapy, which is what we covered actually in our first lesson. And I teach it to everyone now. But, you know, no one knew what oncolytic virotherapy was back when I was in 8th grade. My high school teachers, my middle school teachers didn't know anything about them, and no one I knew anything about them. So when I researched for articles and publications online, every sentence had a minimum of 3 to 4 words. I had no clue what they meant. It was like a different language for me. So I did this, and I made this list of like 100 different terms, you know, that I didn't understand, and defined them and understood them. And then by the 10th, 20th, 10th, 11th, 12th article, I realized that, well, now I can understand everything on the articles because they're all the same words. All of them use oncolytic virotherapy. All of them use PCR. All of them use different kinds of surface proteins. And I can start recognizing specific certain proteins, or recognizing certain kinds of adenoviruses or retroviruses that they're using. And you get familiar with the topic really quickly. Honestly, that process only takes a few days. Like, you can become an expert in these kind of big, complex topics just by doing this research, just by looking into articles online for, let's say, 20 minutes a day. And just in a few days, you can become the expert there. So that's really cool. And that's just some words of wisdom I wanted to impart. But now comes the most important part. How do you reach out to them? Now that you have your professor, let's use, for example, the most recent one. We love this professor. We want to reach out and do research with her because she combines, you know, our heart disease lesson with our IPSC lesson. Well, the way you reach out to them is by using this frame. So this template is something that I developed. One of our SOT students, I was working with them, and they were actually doing public policy research, but I made this frame, and all of you are welcome to use it, copy paste it, and change it as you wish. So this wasn't from online or from anyone else. I made it, and I'm giving you full permission to use it always. And I'll send this out to you as well. So obviously, you can't copy paste this right now, but when I send it as a slide, this is all text, so you can copy paste it here. So let's go over this template very quickly. And if anything is in bold and in brackets, it means it's something you should change, which is fairly obvious. So you say hi for the professor. So hi, professor. I hope you're having a lovely day. This is just a nice cordial greeting. It shows that you're being nice. It shows you're being, you know, it shows goodwill. Then you're saying, I'm a current high school student. And if you're younger or older, if you're a college student, I know for the graduate students we have here, say you're a graduate student, say you're a college student, and say where you're from. But for most students here that are secondary school students, say I'm a current high school student from where, insert your place. I really love that. And then you talk specifically about the project they were working on. So you say that I really love the research you're conducting into cardiomyocytes, and thought your specific modality of, you know, engineering cardiomyocytes from stem cells and then implanting them for XYZ was really promising. So the purpose of this is to make specific commentary on their projects. So a big mistake that some people make is that they send the exact same email to like 100 different professors. And they say, hi, I love your research. Can I research with you? And well, professors aren't stupid, right? These people are obviously Ivy League professors that conduct research that are published in, the top journals like Nature and Science. They're not dumb. They know that they can tell that, this student obviously just copy pasted it, changed like a few words and sent it to a million professors. So why should I even respond to them? Why should I even care? But when you say that, well, I actually read your project. Not only did I read your project, I read your previous research. And I thought that, well, the specific way you did this in the research, like the specific way that you engineered this cardiomyocyte or made this scaffold or engineered this cardiomyocyte for implantation, and you talk about the specific details of their project, then they'll say, wow, this student actually cared enough to understand what I do and research into what I do and said that it's promising. Like professors are people too. They like being complimented. They like being told that, well, your research is cool and I actually loved it. And that's important. And I'll actually get into an example of how you do this for the Professor Koem in 2 slides from here. But then you basically go on to tell them that you have an emotional connection or some interest connection to the project. So a lot of people, again, make the mistake of thinking that you get professors by being the smartest person in the room. That's not true. They want to give back to people that deserve it. So a lot of you that I've had the pleasure to speak with have personal connection to these topics. Some of you have lost parents to cancer. Some of you have heart disease in the family. Some of you have arthritis in the family or have siblings affected by neurodegenerative diseases. So everyone has a host of different conditions that they might be personally impacted by. And it's perfectly okay to share that in 1 or 2 sentences. And it shows the professor that I'm not just emailing this to you for a line on my resume. Like this means something to me. I have a parent that passed away from it, or I have, I might even have this condition of like asthma or something that I'm interested in. So you can give a couple sentences and say that this is how I personally relate to it, and it means a lot to me. And that shows them that, well, if I took this person on into my lab, they would be motivated enough to actually go the extra mile, do the extra research, do everything in their power to learn everything about the material because it means something to them beyond just, a line on the resume or whatever. So include that and say that, well, a lot of you, because you come from areas where it's difficult to learn about this kind of research, where university research opportunities are limited, mention that. It's hard to pursue STEM field careers in STEM fields when I'm coming from a place that doesn't have as much university support. And I would love to learn more about, what you're working with, like cardiomyocytes or stem cells, and be humbled to have the opportunity to help in any way I can. And then what you're doing here is asking for a quick 15-minute conversation about the project they're working on. So what does this mean? It means that you're not right away asking them for anything, right? It might be a lot of commitment for a professor to take on a new student that they've never seen before in their entire life immediately into their lab. Like that's asking a lot of them. That's the equivalent of someone emailing you and saying, hi, I thought you were a really cool person. Can I be your girlfriend? Like, you've never met them. You'd be like, wait, that's a big commitment for someone I don't know. So you want to ease into it, right? I always make the silly analogy that, getting professors is almost like dating in a way, that you want to be nice. You want to show interest in the specific person and what they're working on. You want to show them that they matter, they're special, and they mean something to you, and what they're working on means something to you. And you want to ease into it. So the purpose of the 15-minute call, you can frame it as, I just want to learn more about your project. And this is nice because in the worst case, even if they say, I can't take you on as a student, then at least you can take 10, 15 minutes to learn more about this field. Maybe you'll take something away from them. Maybe they'll even recommend you to a fellow professor or someone else that they know. And that connection alone will establish, a long-standing trust that you can use in the future. So that'll be really, really awesome. So just ask, can I have a quick Zoom call, a quick 15-minute, whatever conversation. And then over the course of that conversation, you can steadily angle things towards, well, I'd love to learn more about your research. Do you have any open spots? I'd love to contribute in any way I can. And even if they say no, you should have a list of asks. So what I mean by this is, you have your primary asks. You have, well, I would love to be able to work with you in your lab. Do you have, like, after, do you have any spots or anything? Let's say they say, no, I can't take you on my lab. They say, oh, that's okay. Like, can I learn a little bit more and can you tell me a bit more about your research? And you learn from there. Then you say, well, lastly, do you have anyone you'd recommend, any labs you recommend that you can connect me with? I just love the field of iPSCs, or I love the field of cardiovascular engineering, and I want to do anything I possibly can in it. And from that, they might recommend you to other professors or recommend you to people that you can approach. And at the end, you might just want to attach your resume. So a lot of people make the mistake of listing out their accomplishments in an email, but look, you want to keep it short and concise. Like this is, I would say, almost a little too long, but it's just, you know, a quick couple sentences and it's easy to read through. I made the big mistake when I first reached out to my professor. It was like 2 pages long. It was genuinely like 50 sentences. It was super long because I thought, you know, the more the better. But professors are human too, right? They'll zone out if you're talking for too long or whatever. So you want to make it quick and concise. So attach your resume as a PDF so that it's just a tiny box and they have the option to click on it, and they can look more about you. But if they don't want to, that's fine. Like honestly, they're not accepting you based on your qualifications. They're accepting you based on your interests. And what's nice is that based on these SOT lessons, you can say that you have some experience in the field of biotechnology. You can say that I've taken a course in medical biotechnology. I learned the fundamentals of lab research techniques, which we'll actually get into later this lesson and next lesson, on gel electrophoresis and midi press and transformation. And that looks good because professors say, wow, they have some research skills, so they're not starting out in the dark. I might not have to, you know, they don't have to start from scratch. They at least understand the basic fundamentals so they can catch on quickly. And then at the end, it's so important that you thank them. So you say, thank you so much for your help and time. It means a lot to me. You show them that you're appreciative of what they're giving you. And then you say, you know, kind regards, all the best, and your name. So I know that was kind of long, but to give you a specific example, this will be one of the last slides on this reaching out kind of block. Let's say I was interested in this professor. So if you actually clicked on her research, I think I included a link in the description here. But if you were actually interested in her research and you clicked on it, and you clicked on the research tab, this is one of her previous, you know, publications that she worked on with designing the fabrication for the scaffolds. So we already covered this in our organ engineering unit. What are scaffolds? They're like the fundamental backbone. They're the base for which we build the organs around. So all she did, so you can read through this abstract. It's, you know, obviously really long, and I don't want to, you know, get too much into the technical details. But essentially, what she did is that she got a unique way to bioprint a scaffold and make it so that it's more fit for integration. So we might be able to mention that in a way for our email to her. So I'm just mentioning that because I incorporate that into the email. But this is just to give you an example of if I was reaching out to this professor, this is how I would do it. And I said, like, this is a random person, John Doe, that I made up. But let's kind of walk through all these different points. So you say, hi, professor, and you say their name. You say, you know, where you're from. I'm from Takoradi, Ghana, for example. And I love the research you're conducting into engineering cardiomyocytes from stem cells to design better implants for the heart. So you're talking specifically about the research you're doing. I really thought that your way of, that's what modality means, your way of optimizing and automating the process of developing collagen microfibers to develop more advanced scaffolds were incredibly promising. Now, that sounds complicated at first glance, but all that means is that she's basically making it more efficient and using bioprinting methods and mechanical coating methods to make these scaffolds, to make these microfiber scaffolds better so that they're more stable and that they're more well fit for heart cells. So you're saying specifically, well, I thought the way that you did that was interesting. So this shows her 2 things. Firstly, the student is smart enough to understand and sum up my research. And if you'll notice from the link that I put in the slide, I didn't copy this word for word. I read the description, I read the entirety of the abstract and the publication, and I summed it up in my own words from what I understood and the parts that I liked and the parts that stood out to me. So some parts, it talked about the hydrogel backbone and everything. I found that less interesting. But this way of automating and optimizing the microfibers, I thought was more interesting. So I decided to list that. So it shows her you're interested in something specific about her project. And then you say, well, this project means a lot to me personally because, and I'm using the example of someone like John Doe, like someone completely random, but it might be like, well, I lost my father to heart disease, and I've been obsessed with the field of cardiology ever since. And that shows in just one sentence, right? Notice how I'm not writing an entire essay about my life story. It's just one or two sentences saying that, well, I have this personal experience. Obviously, it's terrible, and I hope to God, you know, this isn't true for any of you. But you know, if something like that is true, or you know, you have heart disease in the family, you can mention that and say that, well, I'm obsessed with the field. I've connected with it. I'm in love with the field, and I want to learn more about it. And you know, I'm coming from an area where it's really difficult to learn and pursue this kind of research in Ghana, and I want to learn more about regenerative medicine. And I love the work you're doing with cardiomyocyte engineering. So can I have a quick conversation with you? So obviously, when you send this to them, nothing should be in bold. So everything that's in bold, I would unbold. So obviously make sure it's all normal text. But what you might want to bold is this part about a quick 15-minute conversation or quick random parts that you think are worth highlighting or whatever. But honestly, yeah, just make sure that all the stuff isn't bolded so they can, they don't think that you're copy pasting or anything like that. But yeah, that's the general outline of how all this will work. And just a couple considerations for when you have their meeting. So let's say that you sent this out and Professor Koem got back to you. You said, wow, that's super interested that you're working on what you're working on. I think you're a really passionate student. I don't know if I have spots for you, but let's have a quick 15-minute conversation and find out more about each other. So when they respond with yes, and you don't have to do this for every professor, only the professor that said yes to you. So read the entirety of their research. Like, study everything you possibly can about their research and the field that they're researching into. So they might be researching into, I'm so sorry for the background noise, but they might be researching into, let's say cardiomyocytes. So research into everything you possibly can. So type in online, cardiomyocyte research, stem cell research, and go and look at everything that exists online. Be the expert there. Understand all the terms and look at their publications, understand their publications inside out, because it'll probably come up. They might say, well, what are you interested in? How did you find me? You can say, well, I read this Nature publication you had that I thought was so cool. I read this JAMA publication you had and I thought the way you made the fibers and collagens was really fascinating, and how you incorporated hydrogels, and I'm interested in that field. So these are things that you can mention for sure. And then you want to show them that you genuinely love the subject. And this is what I was telling you guys about earlier. It matters more that you love the subject than that you're the knowledge expert. Ideally, you're both, but they're not looking for someone that has, prior publications that is some genius or whatever, because you're just in high school. They want to see you're earnest. They want to see that you can hold down times and that you're reliable. So make sure that you don't, miss the times. Make sure you're always 5-10 minutes early. Make sure that you're always attentive. You're always respectful. They want to see you're a good person. You're interested in the research, and always show how grateful you are. And keep on reminding them, wow, yeah, like I don't have these opportunities at home. This means so much to me. I honestly, even just this 10 minutes of learning from you, it's such an honor. If you make it clear that you're appreciative of what they're giving you, they're more likely to give you this opportunity and say, wow, this is an actually good person. They're interested in the material, and I'd love to give them this opportunity. Like, put yourself in the professor's shoes. You're this esteemed professor who's well reputed, and you have all this amazing research, and you love, and if you're a professor at university, you're probably a teacher, and Professor Koem happens to be a teacher as well. So you love giving back. You love educating students, and you love spreading the knowledge that you have to spread. So if some high schooler said, yeah, you know what, I'm from Takarabi, I don't have any way to learn about regenerative medicine. I love, heart cell engineering. I have a personal connection. I lost my father, and I'm obsessed with cardiovascular engineering. I'll do everything I can to learn about it. Can you help me out here? Can you teach me a little bit more about it? I'd love for you to be my mentor. Why would you say no to them, right? If you have some extra time on your hands, you'd say, well, of course, I would love to help you. So make sure you kind of fulfill all these criteria. And this is my last slide on just this whole reaching out to professors, but this is just to give you some perspective on the matter. So this is like, in general, like you might, and this is the same process I went through, send about 500 or more emails. So some people reach out to about 10 professors and they say, oh my God, I only got one no. So only one professor responded and said, no, I'm gonna give up. Like, when people say that to me, I say, oh my God, are you kidding me? I sent over 500 emails. And out of sending 500 emails, I received 20 to 30 no's. So most people didn't even get back to me, right? Over 450 people didn't get back to me. But like the few people that did said no. They said, oh, we don't have spots, or we can't accommodate. No one said yes to me. 2 people said maybe. We'll see. Let's look onward from that. And from that, there was only one lad that ultimately took you on. So that's the whole process of, well, that's how you go from sending all these emails to getting a final lab. And in the end, when you're talking about the research that you're doing, you only need one lab. No one is in like 3 labs at the same time. You're only in one lab, and you learn from one lab. So, one yes is all it takes, but make sure you reach out to as many labs as possible. So again, make a schedule for yourself. Every day, say that, well, from 1 to 2 p.m., I'm going to send out at least 30 emails every single day. So by the end of 1 month, you sent out a ton of emails, and hopefully you'll get a couple of professors to say yes, and never give up. And I know that's such a cheesy phrase, or sounds cliche, but this is so true. So, like, it took me years before I got my initial research, and it's a really long process. So it's even for people that really love what they do and know everything about everything, it's difficult. So send out as many emails as you possibly can. And you might not get an internship this summer. Maybe you'll get it next summer. Maybe you'll get it 2 years from now, but you'll eventually get it, right? If you keep up at it, if every day you send 10 emails, every day you send 20 emails, you can be rest assured that at least one professor will say maybe. At least one professor will say maybe. If you reach out to 500 professors and not a single one says maybe, or not a single one even gets back to you, I'll give you $500. Really, because it'll definitely happen. Someone will reach out to you. Someone will say maybe. Someone will say yes. And if that's not the case, you should always reach out to more state level universities. So universities like San Jose State, or Georgia State, or whatever, they'll or Florida State University, they'll be more likely. I'm just talking about American universities right now because they're the ones I understand best. They'll be more likely to respond to you, and they'll be more likely to accept you onwards, because a lot of people apply for internships at places like Harvard, Brown, Stanford, but getting it into state universities is a little bit easier because there are less applicants. But yeah, and yeah, so that's the majority of what I have to say on that. And then I was going to go into a little bit on the JMA ambassadorship. So we're going to take about like a 20-second break, and I'll let anyone ask questions that they have in the chat, because I know I covered a lot. So again, we're going to take 20 seconds. I'll see you in 20 seconds. And yeah, type questions you have into the chat for 20 seconds.